In today's video, we're going to talk about coral reefs, and more importantly, why they are so important in helping us understand past environments. Unless you've been living under a rock, you've seen a documentary which showcases corals. They are beautiful ecosystems full with millions of species that are vital for ocean diversity, and they help sustain the oceans in general. And it's due to how corals form and where they're found which makes them such good indicators for past environments. So, how do coral reefs help us? Well, corals typically grow in very set circumstances and conditions. Firstly, they can only grow in the photic zone. This is the upper part of the ocean where sunlight penetrates and reaches the upper waters. Most reef-building corals thrive in shallow, warm waters, generally less than 30 meters deep. This is important because it gives us a reliable marker of where sea level was at certain times in Earth's history. Scientists can use different dating techniques, one of those being radiometric dating, to help us identify how old these corals are. We can do this by using uranium-thorium dating of the isotopes in the skeletons of these corals. I'm coming back to where corals sit in the water column. If we find fossilized coral reefs on different parts of the planet, so this might be high altitude reefs. For example, if we find corals in mountain ranges, we can determine what the land was like before the mountains formed. For example, these reefs would have had to live in shallow marine conditions before the mountains were developed, which means plate tectonics actively occurred after the building of these reefs. Same goes to the other way around. If we find submerged reef fossils deep under the ground, either the sea levels were a lot lower back in time, or there's been some sort of tectonic subsidence, which means a drop in tectonics, compared to where it is now. So that talks about location and sea level height. But corals can tell us so much more. You see, coral morphology, or what they look like and how they grow, is very much determined by many factors. Whether corals are branching, massive, or plate-like structured can be determined by things like water energy levels, light availability, and water depth. They can also access geochemical proxies. They can help us determine what the environment was like where they grew. For example, varying oxygen isotope ratios between 16 and 18 can help us determine what the water conditions were like at the time. An increase in oxygen 18 will imply warmer weather because the oxygen 16 was evaporated and sent up to the sky. If we find elements like strontium or magnesium in the skeletons, that can also indicate water temperature, and then by extension, the climate that the water was in. But the best thing is when you combine coral data with other geological sources. This includes mixing it with sedimentary deposits, microfossils, macrofossils, which helps us make a very comprehensive picture of the seas at that time. Coral reefs act like natural tape measures. They help us determine past sea levels, but they can also be used to help us determine what the ancient environments were like, what the oceans were like, how rough they were, what kind of light was available, and what the temperatures of the climate was like. They offer crucial insights into the interplay between sea level, tectonics, and global climate. If you enjoyed this video, like, comment, share, follow, and I'll see you in the next one.